So here we are going to today doing a project on Twitter gender user classification. So my team has Preeti Gupta, me, myself, Sneha, Preeti Pinghal, Shreya, and Iris, and Jonathan Co. With a lot of structured or semi or unstructured data around the world, it is getting very difficult to make a product or service relevant to the consumers. So one way to handle is this by using user profile as a persona. So that's what we are trying to do here. We are trying to predict the user gender by their user profile and understanding their linguistic quiz. It is very important for businesses to understand their users and drive their service. So we picked our data set from the Kaggle competition, one of the Kaggle competitions. This is the test data set, training and test data set that we have used. So the environment we have used is a lot of classifiers. We have trained our data set on different models. So here are all the libraries that we have used and boosting classifiers we have used. The main pandas and numpy and matplotlib libraries are used to do some basic data cleaning and doing some visualizations to look to really understand how the data looks like. So I'm handing it over to my next teammate Preeti Gupta.
Thank you, Gowtami. Thank you for that. So next we'll briefly go over the data that we are using. We have cleaned our data because this was the data was quite overwhelming, and it was very important to first, before running any model, to pre-process the data, try to first of all understand what's there in the data, what it is trying to say, and also get rid of things which are not going to contribute towards our prediction. So we did the cleaning, and this is a brief, quick overview of what our data looked like after cleaning. There were the number of variables that we used were 10, and number of observations that we used were 13,804. We made sure that there were no missing values in our data set. And here is the total size that we used, our data used in the memory. On the right hand side, we have a little description of how the different variables, what was the type of different variables that we used. 4 were numeric, 5 were categorical, and 1 was Boolean. Out of them, 1 was also obviously the gender column that we are aiming to predict. On the next slide, yeah, so the column of interest for us, which is the gender column, is this is how its distribution looks like. So in the data set that we have, interestingly, we had 4 different distinct values for the column of interest. One of them was female, one of them was male, one was unknown, and another interesting one was brand. So this is the distribution of the of those 4 categories. 33% were female, 31% were male, 29% were brand, and then 5% refused to disclose it. So that was unknown. So this is a raw data set. We further moving ahead got rid of the unknown type, and these were the rest 3 were the ones that we dealt with. Moving ahead, yeah. So these are some alerts from the semi-cleaned data set that we worked on. So description was one of the columns. It was a text column in our data set, and it had a very high cardinality, obviously, because cardinality represents unique values, and description was bound to have different distinct values for distinct rows. So that was something that we were expecting as well, but it was something to be kept in mind while working on the data set. So again, Again, the colors, some colors had high cardinality, the colored column had high cardinality, and text column again had high cardinality. Also, retweet column, interestingly, was very heavily skewed, which tells us a lot about the different type of people in our data set, because retweet count being heavily skewed basically tells us that few people are retweeting a lot, and many people are not retweeting at all. So that's quite an interesting finding to have, and it helped us in building our model accordingly. Um, yeah, so these were some of the findings that I wanted to talk about majorly. As you can see towards the end, the last line that we have added is that retweet count was zero for so many rows. So which says that not a lot of people are interested in tweeting, in letting the world know what they think, but they are not probably retweeting other people's tweets. So yeah, these were the findings. And then moving on to the next slide, we came to the data cleaning part. Okay, from the various classes that we have had under you, we understood the importance of data cleaning a lot. I mean, building models is one thing, but then having clean data is quite important to the process. So we gave enough importance to it and gave enough time to it. It was a very crucial step, and it helped us in building better models. uh, Moving on, I'll tell you quickly, very quickly, I'll tell you what all we did. There's more in the report that we are going to submit, but this is just a quick overview of what all we did. We checked for null values. We got rid of the null rows with null values because we had a good number of data points, a good number of rows. So we could afford to quickly let go of the rows with null values. We dropped unnecessary columns. Initially, we had 26 columns, out of which one was our target column and rest 25. As already explained, we did not use all of them, and they all were not actually, in fact, were contributing to our target column. So it made sense to let go of them. We got rid of rows with missing values. And we also did, since it was text data, it was very interesting for us to do the cleaning of the text data, getting rid of the stop words. Stop words are basically words which actually do not contribute to anything. They do not have any significant meaning, and they lie equally in almost every sentence, like and, a. So we got rid of those. We got rid of special characters. We also made sure that all of the text data is in lowercase, so that there's no bias in the model, and a few other data cleaning tricks that you can have a look at in the documentation. And then we had our clean data ready to be baked for model building. Thank you. I'll hand it over to my friend for further explanation.
Thank you, Preeti. So the next part in our project was automated machine learning tools that we used. We used PyCaret mostly, which is an open source, extremely fast modeling tool, because we were handling a lot of data. We wanted to try different models and have them all run at once with cross-validation while we were doing so. So PyCaret, if you don't know about it, tries a default set of hyperparameters to provide the best results on accuracy or AUC or whatever metric you're looking to sort them by. And so this is just an example of when we first ran it with our semi-cleaned data, that it would run all these different algorithms like k-nearest neighbor, decision trees, eta boost, gradient boosting, naive Bayes, ridge classifier, logistic regression, random forest, SVM, and light gradient boosting. And as you can see, light gradient boosting was the highest accuracy as well as the highest AUC. And so right out of the box, we got 58.08% accuracy. We also wanted to include that even though LGBM, light gradient boosting model or machine, has the highest accuracy, on this list, it also has the highest AUC. And that's important because this is a classification problem. So the AUC is important to our modeling and predictions. And so this was one of our main focuses when creating our own models outside of PyCaret. So some feature engineering that our group did was we introduced those text columns. So like the description, we assigned one-hot encoding vectorization to those text columns. So each column would begin to be 500 columns of zeros and ones. We assigned those one-hot encoded columns to be data type int8 instead of the default int64, so that it would speed up our calculations by not having to save as much memory. And time after time, we would keep throwing this back into PyCaret, seeing what the results are, and we would increase the vectorization from 500 columns per text column to 1500 and then 2500. And I'll show our results in a second. The only thing about this is by increasing your number of columns, you obviously require more computation power and more time. So the next thing we did was reclassify the gender column to zeros, ones, and twos, where 0 and 1 are male or female, and 2 is if it's a brand and not a male or female. We then introduced the link color feature into our models, and we converted the link color eventually from a hex code, which is like the number sign with 6 digits representing RGB values in base 16, to RGB values alone of like 0 to 255. And then from using those 0 to 255, we could determine the actual color name of the color. So there could be like light blue, blue, dark blue. And the last thing we did for the color part was to remove the word light or dark from the color if it existed. So all the blues would be essentially matched together. All the turquoises would be matched together, reds, orange, yellows, etc. And then finally, we brought back in the numerical favorite number data column as categorical data. And so if we go back a slide, we can see that our accuracy was 58%. So after doing all of this feature engineering, our accuracy score actually improved to 66%. We can also see that even though the accuracy improved all the way from 58 to 66% or 65.99%, the AUC also went up from 76.75% all the way to 82.11%.
So let's have a look at the visualizations and see what insights we can derive from those. So here, looking at the plots, we can see that when we check between gender and number of times they've created a tweet, in case of female, it's high, suggesting that they're more actively expressing their appreciation. Whereas the retweet count and tweet count is highest for brands and then males. Interestingly, the number of retweet counts is lowest for female gender, which implies that even though the post does not fit the content, they still appreciate the tweet nonetheless. Can you go to the next one? Here is a density graph of Twitter account versus the gender. We can see that this is highest in case of female gender. So when they're engaging on Twitter, they're more active than men or brands there. This is the text length versus gender. We can see that there's a normal distribution and how they differ among gender and the brand. So this is visualizing between how each gender and how they're using the sidebar colors. There's little variations in the sidebar colors among different genders and brands. Compared to the sidebar colors, we can see that there's more variation when it comes to link colors and genders. Um, for females, we can see that it's pink and purple seems to be most popular choice of link color, whereas from the male gender, the shades of blue and green are more popular. There's more overlap between brands in male than between brands and female. That is, the shades are more similar between brands and male.
And we did the word cloud based on the text column, but for both female and male. And the main idea is, although overall the way people use language is quite similar, but by taking a close look of these texts, we observed some interesting difference between genders. I think first is male, they tend to talk about their own feelings more. And for the female, the text content has more daily life stuff, such as friends, work, or life. We can see it. And the second find out is the degree of certainty are slightly different. And the third one is we found out female use more upper comma. That one, for example, separate I and M as I am. Male tend to use the lazy typing without upper comma more. And another one is for the unique high frequency words. There are some words like gains and hope and into appeared in the male's word vocabulary. And another interesting part is no matter how I set up the stop words, the love is always take a big part of female's text, while the men use like a lot more. And also overall, men likes to use guy to describe themselves, and the woman likes to use girl to describe themselves. So we can tell maybe the age group of this Twitter, the owner of the account owner of the Twitter may be quite young. So I will let Shreya to talk about more about the overall of the models.
Thank you, Alice. So, yeah. So we already have an idea about what model is going to give us what kind of accuracy based on what we got from PyCaret. But still, we wanted to use different models and see how the accuracy is going to come up based on non-text and text columns. We have not used any kind of sentiment analysis into these kind of model predictions. So we have just used the columns and found what predictions we're getting. So this is the first predictions that we did. It is using the non-text column link color. We specifically chose link color because link color, we had some variations that we saw in the visualizations, and some conclusions we could draw on the gender based on the link color. So if we see the accuracy scores that we are getting, it's actually not very high. It's somewhere between 35 to 44, 45. It's not very high accuracy, and logistic regression is giving us the highest accuracy score, whereas SGT classifier is giving the lowest score. We also try to use ADA boost into it to see if that boosts the accuracy score, but maybe because of the presence of noisy data, ADA boost is actually giving quite a low score. And see what kind of predictions we are getting when we're using a text column. So text column is basically the tweets that users are tweeting. So based on the text that they are using, we are using them to find the predictions. The prediction accuracy scores is slightly better than what we got when we were using non-text data, but again, it's not very high. SVM support vector machines is giving the highest accuracy, followed by SGT classifier. But surprisingly, AdaBoost has the lowest accuracy. We can see there is a little bit difference here than what we got from PyCaret and what predictions we are getting here based on the columns we are using. If we incorporate even description along with text, so that we have a more holistic view of the profile of the user, we are getting much significantly higher accuracy score than the previous two predictions. But in this case, SVM is again giving the highest accuracy, followed by naive Bayes. And accuracy has jumped from 30 to 40% that we were getting when we were using non-text to almost 62%, which is nearer to what PyCaret was also giving to us. KNN has the lowest accuracy. We used for N5 KNN model, and again, AdaBoost is not increasing the accuracy score to a great extent. It's only at around 0.5. Here we have summarized what all we did with the Twitter data that we are using. First, of course, we need to understand what is the data, what kind of cleaning goes into it to make the data much more productive and much more usable, so that we can gather some usable insights from it. Once we had cleaned the data, we used PyCaret. PyCaret is basically an open source machine learning Python library. And using PyCaret, all this machine learning task is very easy. The only problem is it is very time consuming and it requires a lot of computational power. After that, we also implemented some feature engineering techniques to see if the accuracy score goes high while using PyCaret. It actually did increase accuracy score. We did one hot encoding the text data. We converted the link color to color names. We also played around with the vectorizer. And once we were done with the feature engineering, we moved to visualization to explore the data more and gain some analytics from it, so that we have a proper understanding of what is the relationship of the data with the distribution and how it can help us to gain more predictions. We did a visualization using the Twitter count, the retweet counts, the tweet counts, or whether it was a word cloud, and we could gather some kind of insights based on those kind of visualizations. Next, we moved on to models, so that we implement various kinds of models and see what is the different accuracies we are getting, and if the accuracies differ based on the features we are using, and what is the best features for the predictions. So we used over more than 10 models to find the predictions, but overall we could not conclusively say that one particular model was working or giving the best accuracy for all the features. Overall, we saw that SVM did give a better accuracy, but it's not very conclusive. We tried to play around with boosting also, and we did LGBM classifier. But overall, even using the LGBM, we got accuracy around 56 to 57%. We have that in the Py book, in the IPYNB file also. So yes, so this is our overall Twitter gender classification presentation. So thank you, everyone.